2 to the p plus 2 to the q equal to 2080. P and q are integers. We want to find p and q. Let's first consider something. For example, look, if we consider 2 cubed plus 2 squared, then you can factor from 2 squared will be 2 plus 1. Okay? Because it is 8 plus 4, so you factor from 4 is 2 plus. So we will see this part. And now, first, we will see it is 2 to the power of something times an odd number. Okay? So we want to see 2080 is 2 to the power of what times an odd number? And first we consider p and q are positive integers. Okay? P, q are at least 0, let's say, not negative. And then we prove that if one of them or both of them negative, we don't have any answer, it's obvious. We will prove it. So PQ are greater than or equal to 0. So if we consider focus on 2080, multiple of 4, multiple of 8 also, if we divide by 8, it is 2, 8, 16, 48, 6, 0. Then it's multiple of 4, 8 times 4 times 6, 25, 60. That's good. Now we can say 2080. 8 times 4 is 32, is 2 to the what? 2 to the 5 times 65. It is the odd part. Okay. So as you can see, 2 to the 5, the odd part is power of 2 plus 1. You can say it is 64 plus 1. So 2080 equal 2 to the 5. 64 is 2 to the 6 plus 1. Equal to 2 to the 11 plus 2 to the 5. Okay, so you can consider PQ, one of them 11, one of them 5, or 5, 11. It was this. Now, it was case 1. So if both of them are at least 0, you can, it has also another way. Because when P and Q are at least 0, you say, okay, if we wanted to prove with other way, let me tell you solution 1 here for this part, solution 2. You could say, okay, for example, without loss of generality, suppose that P is less than or equal to Q. So you can factor, you can say 2 plus P plus 2 plus Q. You can factor from 2 plus P, it will be 1 plus 2 Q minus. So the only possible case here, it should be 2 to the 6, 2 to the 5. Here, it should be 65, the only possible case. Okay? And, okay. So in this case also, we conclude P is 5, Q minus P is 2 to the 6, 64 is 6. So Q is 3 plus 6, which is 11. And we can switch. As first we say without loss of generality, P less than or equal to Q. Okay, so it was the first case PQ greater than or equal to 0. Now I want to prove if here, for example, one of them less than 0, Q greater than or equal to 0, it's impossible because we know 2 plus P plus Q is 2080, but 2 to the P is not integer. Because look, for example, 2 to the negative 1 is 1 over 2 to the negative 2 is 1 over 4, and so on. 2 to the Q, what is integer? Because Q is at least 0. 2 to the P plus 2 to the Q, some of them is not integer, so we know some of them is 28. 2080 is not integer, which is contradictory. It was second part. Now let's focus on third part. Third part, both of them less than 0. If both of them less than 0, 2 to the P plus 2 to the Q. 2 to the P is less than or equal 1 over 2 to the Q less than or equal 1 over 2 less than or equal 1. But it is 2080 and it's impossible. Again, contradiction. So our only answer is this. 11, 5, and 5. 11. If you have questions, send message to my WhatsApp number. Please don't forget to subscribe, turn on the bell, and like the video. Thanks. Bye.